can start with this section, and I will cover ThinLink in Rstudio. And if I have time, then I will cover something about the interactivity in HPC2N. So regarding the ThinLink, first of all, you need to install the ThinLink client, right? So then in the server name, once you install it in the server name, you can write kebnekaise-tl.hpc2n.umu.se. Then your username and the password that you got for HPC2N, not the password that you got for Super. So something that is recommended is to click on this option here that is called window, right? So that you can resize the ThinLink client once you get login into the machine. So then once you fulfill these inputs, you connect, yeah, and you will see some interface like the one I have here. Yes, and you will also see some menu bar, yes, appearing on either on this side or on this side here. So it depends on your configuration. So in my case, because I modified my configuration, I can see my menu bar here at the top, and also I use something to hide it because this gives me more space, right? But you should get something different, most likely on this side here. So here on the menu bar, there are several applications that are already installed. And for the particular case of Rstudio, you can find it here under programming. You can see that here there are some tools like Atom is an editor, Emacs is a text editor, Matlab with different versions, and Rstudio is already there. So if you want to get Rstudio, you can click on this application, but this is something that I don't commonly do. Yes, except for trying something fast. So what I do is something different. Yes, and I will show you right now. So here on the terminal, I go, yes, I open the terminal. This terminal can be obtained from the menu bar, and then you go to System Tools. Then a trick that I use is that just the first time, I click on this icon, and then I drag the icon on the desktop, right? So that always I have it available, and then I only click on this instead of going to the menu over and over. Yeah? So here I am on the terminal, right? And what I usually do is that first of all I load the R version that I want to use. In the particular case, in this lecture, I will talk about this version of R. Yes, but you can use other versions as well. So I load the modules, right? Now the modules are loaded. Then here on the terminal, I type RStudio. Yeah. Then execute this command. And here I get the Rstudio graphical interface. So this is an update message that I will ignore because we as a users cannot update the Rstudio. So, so only the system administrators. So in here you can start working. So if you're careful about this message here, you can see that the RStudio version is the one that you loaded on the module, as you can see here, the same version of R, yes. And this is important because then you can control the version of RStudio, the version of R that RStudio is using, right? And another good feature from this way of opening RStudio is that it inherits the working directory as the one where you open RStudio, right? So, and this is why I prefer to use RStudio by opening it on the terminal, yes? Or otherwise, if I open, for instance, RStudio from the menu here, then you won't get the working directory as the current directory where you were sitting, but instead you will get a general directory. For instance, in this case, the working directory is something general, as you can see here. Here, if you open the terminal, you will see some working directory, which is not the one where I was supposed to be. Yeah? I need to move there. If I click on this button here, then I will need to choose the correct path to my files, and it can take longer. Another thing is that if I open RStudio from the menu bar, you will get some default version of R, which is the 4.0.4, and maybe this is not the one that we wanted. So in my case, I wanted this one, right? And to force RStudio to use it, and also to get the correct working directory, I open it from the terminal. So then here, once we are on the GUI, we can start working. So we can create, for instance, a R script. Yes. And we can start working. We can save the file. For instance, here I save the file. And notice that it recognizes that I am working on R workspace, which is this directory here. So I will save my script. I will call it script.r. And it should be now in my R workspace, as you can see here. So RStudio must be used for lightweight tasks, as I am doing now, for editing, and also if you have some visualization that this is not computationally heavy, then you can just execute the code, and then you can get some pictures here, some graphics. That will be convenient because in that way you don't have to put your files back and forth, yes, to modify them and also to visualize the pictures. But otherwise, if you want to run something heavier, then you need to create the batch script that Birgitte mentioned previously, and that will allow you to put the job in the queue. Okay, this is the part for R script, for Rstudio, sorry. And then I can talk a bit more about, let me see how I am in time. 45. It should be okay. So then I can talk about the interactive work on the compute nodes, but for Kebnekaise only. So we have seen that it's possible to run Rstudio here on the login node. Notice that here I am sitting on the login node in my thin linked terminal. But for heavier jobs, right? We need to submit the job to the queue. Yeah. And there are other ways to do some more interactive works with our cluster, right? Here, there is one way to do this. So in particular, we can use the command called salloc that will allocate some resources, yes? And this is the number of tasks that will be allocated. And here you specify the time, and this is the project that we are using now. So in this way, you will allocate some time not on the login nodes, but on the computing nodes, right? So this is important, the number of tasks, yes. And here we can specify if we have only one task, then we can specify n equal to 1. We can run this command as follows. So first of all, we need to load the module ML and the module that we want. So we did it already. And then we can do the allocation with salloc. So somehow it's taking time to load the modules, which was not that common, but now it's taking some time. And then we can do, for instance, I will modify my script that I just created for the a equal to 3. And then I will print, let's say, a. So then I open or reserve some time with one task only. And the time that I want, it will be just 1 minute. And the project, yes, notice that this is called more interactive because you don't need to write this as a batch script, a batch file, and also because you can execute the command or execute the script when you feel comfortable about that. So HPC2N is a project 2024, and then the number here. So now imagine that I modify my script. So the job has been, or the resources have been allocated, and they are now on a different node. Notice here that there is a different node. The login node is this one. So I have time here. And if you take a look at the queue, you will see that the job is placed there. So I have reserved some time there. Yeah. And here Now I have some allocated nodes for this job. And in order to run the script, I don't simply type, for instance, R script and then script.r. Yes, because if I do this, I will be running the script on the login node, not on the computing node, which is this one. To tell R that I want to run the script on this node, the computing node that we reserve with salloc, we need to use srun command. Yes, before the R script. So it tells me that the time has been exceeded because I requested only 1 minute. So this time I will request 2 minutes. And then if I want to run the script, I will type srun and the name of the script. So again, don't use only R script and the name of the script, but use srun R script once you allocated the time with this command here. So very important, if your program, for instance, uses several workers or several threads, as if you are doing a parallel programming. For instance, if here in the script you are making use of a cluster, right, with some number of threads, for instance, 4, then the proper way to initialize salloc is by using -n1, which is one task to execute, but use C as the number of workers that you want. Yeah. So this is very important. What happens, for instance, if instead of using C equal to 4, you use N equal to 4? Yeah. So this is a big difference. So let me first cancel the job. So my job is still running, so I will cancel it. Let me show you the difference between -C and -N. Let me see if I type N equal to 4, which is 4 tasks. Okay, and then I run the command srun R script. You will see that this task here, which is R script, was executed 4 times. Yes. So this is not what we want, because we want the task to be executed once, but to have some other cores available. That's why instead of running this type of job, we use -n equal to 1 to run one task, but also specify the number of cores to 4, for instance, or whatever you want. That is not beyond the number of cores in our system, in our node. And then you can execute the script with this command. And you will see that it is executed only once, right? Which is correct. It's one task, and here is the number of tasks, of course, per task. Yeah? That's an important distinction that we need to do. So we have also covered thin link. You can have a look at the alloc that I mentioned now. Here there is some exercise or example that you can take a look at. So this is very important. The number of tasks and the number of cores per task. So once you want to finish or to cancel this allocation with salloc, you can do several things. One is to type cancel and the name of the project, or you can type exit, yes, to relinquish the allocation. So is there any questions about this? Do you think you can work now with the Rstudio and Thin Link and submit the job?